My name is Sabo Achidoku Emmanuel. I'm a blockchain developer, and I'm currently the community manager at BlockOps. So I believe most of you know me physically, and yeah. So today I'll be taking you guys on introduction to Starknet contracts. So I was here for the solidity period, and I believe most of us are familiar with contract. So, but just as a refresher, what's a contract? Who can help us out? What's a smart contract? I'm asking, okay, okay, excellent. So, does anybody have anything against what he said? Self-executing code that run on the blockchain. That's what a contract is. Are we anyone has a better definition? Okay. So, so what's Starknet? How about Starknet? We're doing introduction to Starknet contract. So, please, I would like you guys to let's make it interactive. Yes, sir. Okay. So cool, cool. So okay. So okay. We'll be looking at the contract architecture just to see the blueprint of a contract. So just as you said, Cairo is the programming language used for Starknet smart contracts, just like the way we write Solidity for Ethereum and other EVM language and chains. Thank you. So I don't think I need to say much. So let's start discussing about some terms in the overview of Starknet contract. When you hear the concept contract class, so think of a contract class as a template or a blueprint. It contains the compiled Cairo bytecode. You understand the concept of bytecode? Hmm? You said? Exactly. So then the ABI is like the application binary interface. It's just like I dare to also call it the skeletal framework, or you can call it the blueprint of the code you write. If and when you want to interact with the contract, probably from a front end or so, you can use the ABI to direct your call to the specific functions and stuff. So okay, so you can declare before you to deploy a contract, you need to declare it. For those of us that have written Cairo smart contract, it's not like the Solidity contracts that you just write it and you compile it and you can just deploy it. For in Cairo, you need to declare an instance of that contract before you can deploy it. So okay. Contract instance is deployed copy with its own storage and addresses. After declaring a class, you can deploy it as an instance. Yes. So each instance has its own contract address. Yep. Yep. Please hope I'm not rushing. I'm not too fast. If I have, like, is there anything you'd like to bring me back to? For now, no. Okay. So, entry point. When we talk about the entry point into a contract is how we assess the logic on the contract to make it do what you want it to do. I don't know if we're together. So, okay. So the concept of EOA is like we have in the Ethereum. It's somehow different in here because here all wallet addresses are like contract addresses. That's why if you create a wallet, either Bravos, Argent, yes, you deploy the account. So okay, so yes, that's what I said. When you write a contract, you declare the contract before you deploy it. Are we together? I'm just trying to make the foundation as simple as possible. So now we have another concept, traits and implementation. So traits in Cairo are similar to interfaces in Rust or abstract classes in other language. They define which function a contract or a module must implement without specifying how. Why they matter? They encourage polymorphism. Different implementation can satisfy the same interface. They promote code reuse and separation of concerns, making large projects easier to maintain. So just like it said, think of traits. Let's say, for instance, now you have boy. You understand? Boy. Boy can have traits. Just look at traits like method. Can have run, walk, eat. You understand? And the contract, or you must the if you once you want to define the logic, it must implement all the traits that you have defined. I don't know if we're together. So it's just like, let's say if you have a struct, if you are creating a struct, you can define the traits of that custom type that you define. Hope you guys did data types already, because I'm working under the assumption that we did data types. We're together. So then, okay, good. So this is an example of how to implement or to provide the actual, like now we can have a trait I counter. Okay, this one is in form of an interface. Then you can do the public implementation, counter implementation of I counter. You guys have written Cairo code before? Okay, so okay, but not in class. In our no. I mean like in our last class. Oh, okay. Okay, so now I think I'll show you, but you guys have installed everything you need to install. Okay, so I think now let's just create let's we can create a folder. You don't even need to create a folder. You can run scab new, and let's do Starknet contracts. Yes, then so this is the way you spin up a Starknet contract. Use the word scab. I believe you guys installed scab, ASDF, Rust. Rust is primary. Everybody has that on his system, yes? So I think you guys can work with me now. So let's do this thing together. So then I can cd into Starknet contracts, and I can open it. Are there people online? Let me see. There are no people online yet. So, okay. Are we here? So, okay. So let's look at this structure. Let's see what's happening here. So we have, okay. We have two folders, big enough. So, okay, so let's go through this. We have the source folder. This place contains all our files and modules. That's what we put here. Just like for those of us that are coming from other languages, like the source folder, when you use JavaScript frameworks, where you put all the code that you're going to execute. Yes, it's here. Then we have the test folder, where we write test for our contracts. So as usual, the git ignore. I think for files we don't want to push to main. Then think of the scap.toml as like our, yes, exactly. Thank you very much, Uche. And we put most of the dependencies. If not, you put all your dependencies here. Anytime you want to add a new dependency, you add it to your scap.toml. So please, are we together? Mm-hmm. Are we? So what will I have in my, if I want to add a module, let's say I want to write a contract in a particular file. Where will I put that file? Sir? Source. Okay, okay, good, excellent. So, how many of us have spinned up the? How many of us have spinned up? We have spinned up the a local contract, spin up Scarp new. Okay, okay, nice, nice, nice. So, so the next thing we're going to talk about storage. So, so in Solidity, I'll always be making reference to Solidity because I know most of us, if not everybody here, has Solidity knowledge. So yeah, for when we talk about storage in Solidity, what's storage, please? Like someone can help me. So okay, no. So storage in this instance is when you talk about storage in Solidity, you talked about the blockchain itself. Data stored, any data stored in storage is stored on the blockchain itself that needs gas to be manipulated. I remember I spoke about this here. Understand where we have storage, we have memory, and we have the third one. Huh? Yeah, correct. Called data. So good. The entry point again to our Cairo program is the lead.cairo. This is where everything you are going to work on. This is going to be the entry point. Like this is where if you want to run or compile it, it comes directly here. It comes to the lib.cairo and see, okay, what is there? I don't know if you understand. When you run it, it runs when you build or you run a Cairo program, it runs the lib.cairo. Are we together? Am I making sense? Harold, are you with me? Okay. So let's see. This is a boiler template. When anytime you spin up a project, this is the first. This is what comes with it. So let's use this one and go through the architecture of a simple contract. You understand? So now the first thing we see here is what? What are we defining here? So it's an interface. And I remember, so what's an interface? Yes. So yes. So the interface is like a blueprint. It allows you to define the functions you want a contract to implement. So here, this is a public interface. It's a public trait. Hello. Remember we spoke about trait and implementation. You remember just 2, 3 minutes ago, we spoke about trait and implementation. So the trait is the behavior that you want the implementation to obey. You understand? So trait and implementation work hand in hand. Anywhere you see a trait, there's going to be an implementation for that. Are we together? So now here we're making it public. It's a public trait so that this trait can be accessed from this trait can be accessed once you can locate the file. Once you can find the path to the file, it will be accessible externally. Are we together? So we have a function. We have two functions actually. The first function is increase balance. So for Starknet contracts, we have two have two type of functions actually. We have the read functions and we have the write functions. We all know that, yeah. So every read function must reference self. It must reference itself. Yes, sir. Okay. Okay. So now we're defining a trait here. Are we together? Like from here to here. This is just like saying contract ERC20. You understand? This you are defining a public trait. Let's make it like this. This is an interface. You are defining an interface. And that interface has a public trait. Huh? And the name is what? I hello Starknet. Where is that coming from? From my PC? No, it's not me. So okay. No, it stopped. So it's that's the name, and this is the type. It's a contract state. Are we together? So you can use it as T. This is just like you can use it as T, but you now have to mirror this guy to be T. You have to mirror this guy too to be T. You have to mirror this guy too to be T. I don't know if you understand. So this T is just like the type we're talking about. So it's a contract state, okay? So it's crying because it's not matching, but now yes, everything is okay. I don't know if it makes sense. This is a public trait. Once you want to define an interface, yeah, it's a public trait, then the name. Then in this less than and greater than, it's the type. It's a type contract state. Are we together? So the first one here is a read function, and the major difference between the read function and the write function is the first argument of a read function is a reference self, or is even the first argument of a Starknet function itself. Are we together? Is the contract itself. Like for the read, you ref self. Then for a sorry, I'm mixing it up. For a write, this is how you write. You reference self, T contract state. Then for the read, it's a snapshot. It's like a snapshot. You understand of the current state. Confusing a bit. Okay, so let's take it one at a time. So okay, what's ask so that it's easy if you ask, then I give you an answer instead of pushing information on you. So it's a bit confusing. So let's start. You can just see from the first one, then walk through it together. Okay. So, okay, I want you to look at it now. You see, one is referencing self. Are we together? You can look at the code. Ref, self. You understand? Anywhere you see it referencing self, it's a write function. You understand? Then the second function, get balance, is a snapshot. You see self at T contract state. Yes, like this is a snapshot of the current state. You understand? So once you see that as the first argument, a snapshot, you know that okay, this is a read function. We are reading the current state of the blockchain. Are we together? Mm-hmm. Mm-hmm. No. No, let me be clear. Like a snapshot, your code has storage. You understand? And if you upwrite a transaction, it's saved on the blockchain and your own contract too is updated. Understand? So that snapshot is giving you the current state of your contract on the blockchain. Like if if one if A is one and there's a function that says A equals to one plus one. Yeah, if you call that function and you now call get A immediately, it takes a snapshot. Like that art is just a snapshot. I don't know if we are together. Yes, and returns it to you. So are we together? So I believe we have manipulated felt. Have you done that? Felt is the data type that holds short strings. Yes. Then if you want to use longer strings, you have byte array. Yes. Then we have you 8, you 16, 32, 64, 128, and 256. Yes. Good. So now that's all about the interface. Are we together? So if you want to add more functions, you can add more functions. But remember, every function you define in the interface, you must implement it. Are we together? Are we together? Okay. So now, this is a contract now. This is a Starknet contract. This is a simple hello Starknet contract. So this line here is reading storage. So we want to use the storage pointer read access, storage pointer write access. So it allows us to the storage pointer read and write access allows us to read and write to to storage. I don't know if you understand. So like in Solidity, you remember when you create a public state variable, you get a getter function for it. You understand? But here there's no public or private state variable. Are we together? Like so, we need this storage pointer to read and write to the storage. So now in Cairo, our storage is a struct. You know, in Solidity, you just write it outside the function. Please, am I making sense? Solomon, you're looking a little bit like you're not here. Okay. So what? So this is all your storage variables. You write them in a struct storage. You understand? You define it just like the way you have interface, you have contract, you have storage. Yeah? Are we together? So here we just have one storage. It's just a storage variable. It's balance and it's felt 252, which means it's a short string. So now this is the contract implementation, this block here. Remember, this block it's going to be inside the contract module. You see the whole I like using these tabs to close work and so that we can see. You see here, this is the interface here. We're done with the interface, right? So now this whole module here from 13 to 32 is the contract. Are we together? So in the contract, um, we have the storage. You understand? That's where we save all our storage variables. Are we together? Hmm? Then so now this is the implementation. This is the name of the contract is Hello Starknet. So this is Hello Starknet implementation. Pay attention. Hello Starknet. This is Hello Starknet. Hello Starknet. Sorry, implementation of super. Do you know why it's super? Do you understand the concept of inheritance? Yes. So now they are yes, I'll call it inheritance like the way we do it in Solidity. When you have virtual and override and all those stuff. So now super is because this module is outside. So it's like when you use super, it's like you're bringing them into the same sheet. I don't know if I'm saying it right. Saying it right. Yeah. So super is just like this guy up there. I'm bringing it down here. We're bringing it inside this Hello Starknet module now. So everything that's here will be accessible directly here. Are we together? So, and this is the type again. Don't get confused. So this name, it has to be the name of what you are bringing in. I Hello Starknet. The public trait I Hello Starknet. So what we're doing here is the implementation of I Hello Starknet. So I Hello Starknet is just like a blueprint. It's just a blueprint of what the implementation should hold, and it's supposed to hold just two functions. Are we together? Are we together? Increase balance and get balance. So if we open this implementation, we're supposed to see how many functions. Exactly. So you see, we have increased balance. I told you, so it has to be exactly the same. The signature has to be exactly the same. Takes in amount and felt 252. You see, it takes in amount felt 252. Are we together? So this is like a security check. You should assert the amount is not equals to 0. Are we together? Then now, good. This is where it gets. This is where, yes. So this is where we use the storage pointer that we implemented up. That's this read access and write access, so that we can able to write and read. So when you are trying to get, if you are reading, I don't want to confuse you, but when you want to get information, you are reading, yes. When you query the blockchain for information, you are reading, yes. So you can query The storage, that's the self now. Self is referring to the contract itself, yes. Because you can do self dot get balance, self dot increase balance, yes. So now self dot balance dot write. That's why reading balance here. If you want to manipulate anything in storage, use self dot the variable name dot write to change it, dot read to get the value. Does it make sense? So now, are we together? So if I want to get the value of balance, how will I assess it? How? Self dot balance dot read. It's looking at you self. Yeah. Do I need to pause? Technical crew. Okay. Okay. So are we together? Are we together, please? Okay. Yeah. Okay. Okay. Let's do something now. Let me add one extra step. We can do U256, I think, updated amount. It should not be equals to self dot balance. Let me make it very, let me break it down for you. What's happening here? U256. What's wrong? What am I doing wrong? Yes, I'm writing it like solidity. Thank you. I'm doing it like solidity. I could do it like this if I want to give it a type. Yes. Yes. Yes, sorry. After the variable name, you see, my head is a little bit hot. Now this is 256. Yeah. Okay, that's if I want to give it a type. Okay. Yes. So I'm commenting this. I want to answer your question. You said it's, sorry, I'm coming. Yes. I'm going self dot balance dot read. Wait, let me get this thing. Sorry. Okay, it's the type. It's felt. It was felt 252. It was felt up there. Balance was it felt. So this line 26 that you said you don't understand the right, yes? So now this is the current value of balance. Are we together? Then we can update it by adding amount. Are we together? Are we together now? So now you can now come and make it, we'll now come here and we don't need plus amount again. So it's less bulky now, but it does the same thing. It's a little bit bulky now, but it does the same thing. So what happened there was doing everything in a line of code. Like, let me explain what I mean. Control C, Control Y. So line 26 and 27 is the same thing as line 29 in one line. So you are doing, sorry, it's not updated. It's amount, self dot balance or read. Is this? Are we together? No, you don't. You don't have to. Because we want to update balance. We're adding it. It's just like doing balance plus equal to amount. You understand? So you don't want to discard, you are not changing balance, you are manipulating balance based on the current state of balance. It's not like for every time you want to manipulate state, you do that. Are we together? Oh, okay. So to get balance, we just simply read. You understand? And this is in Solidity we use returns. For here, this is how you return a type. You can return a tuple, you can return an array, you can return a struct. Are we together? Are we together, please? Okay. So let me go back to my slides. My slides are not much. Someone is saying my slides are much. So now mapping. So let's talk about mapping now. So what are mappings? What are mappings? Okay. What are mappings, please? People, what's happening there? What are mappings? Okay, yeah. It's a key value pair. Yes. So it maps a key to a value. We did this in Solidity, when we wanted to do balances and addresses, where an address will be tied to a balance. Hmm? So I think for us to be able to use mapping, we have to bring in storage here. Are we together? You have to bring in map, then you bring um no. You have to bring map read access, map write access. But let's take it one at a time. So you can come here, then you can do okay, we can do another one. I call it balances. Balances. Okay. Okay. Yes. So we can use this as contract. Let's use contract address, but I think it's going to show an error. So we have to, in this module here, what's happening here? Nope, this is an error. Yep. So, yeah, so now I have to use Starknet contract address so that we can use contract address. Are we together? So this is how you define a mapping in Starknet. Balances is the name of the mapping. Are we together? Line 21, balances. Then we're mapping. So now here the key is the contract address. The value is what? Are we together? Huh? Are we together, guys? So now we can also bring something else from Starknet. We can bring the get caller address. Get caller address. So this get caller address is synonymous to your msg.sender. You just joined? Are you following? Okay. If I'm seeing anything that doesn't make sense, please feel free to bring me back. Are we together, guys? You're looking lost. You that is turning, I lost too. If you are, so are we together, please? So we can just, so now we can come here, we can just add so that we can track balance to be unique. Everybody should have a unique balance. You get? So we can just, first I can say let's color should be equal to get color address. Sorry, AI is helping me a lot. Then we can do nope self dot um, balances. Yep. So okay, so we don't have there's something we don't have. We don't have the map read access. I think it's map read access. So let's go to Starknet by example. Let's see if I can get it from here. Okay. So we'll soon be going for a break. Yes, Starknet, for example. Why am I having problem getting? Okay, okay, I can use Cairo book. Then I can look for mappings here. Yeah, or where to search. Okay, good. So hope you have access to internet and you can hope I'm not killing the call. Okay. So hope you have the Cairo book exists so that if you have any confusion, if you are looking for something to implement and you don't know how to go about it, perhaps there's no mentor accessible already available. You can use the Cairo book. So okay, yes, okay, storage part and three. No, I'm looking. Okay, I don't think this works again, but does it? Let me try. Into color dot right self dot. Let me try this and see color dot right. I used to use this pattern. Mm-hmm. Okay, we haven't brought it. Mm, let me see because I used to use another method of reading and writing to storage. But let's see. Okay, it works. Wow, that's awesome. So this is how you write to a mapping, a storage mapping in line 33. I think there's another way. I'll challenge you to go and find that out. Or if we come back from the break, I can show you the other method to write to it. So you see, this is simple. Are we together? So every time we okay, no. It's not going to be smart. It's not going to be smart. This is not going to be smart. This is not going to be a smart way because every time we update the general balance as the user's current balance. You understand? So now we'll find a way. Let's read, and to read, this is okay. This is just the code to read. So let's read. You now do you do let's unique balance is equals to self dot balance is dot read dot entry dot read. Now, are we together? Uh, then you now update. This is where we're updating it from. Unique. Uh, we're going to update this unique balance plus amount. Does it make sense? So that every color will get the color's balance before we update it. I'm just showing us how to read and write from markings here. Is it making any sense? Like, am I leaving anyone behind? There are no responses. Please. Okay. So, okay, I think that's what I'll do before our break time. Um, mapping here. So good. The first thing I said was for you to use a map, you have to bring the map from Starknet storage. Are we together? Then we brought in the storage path N3. Are we together? So we brought in two things to be able to use the map. We brought in these two storage pointer read access, storage pointer write access are for you to be able to read and write from the storage. You understand? So you need to define the data type map. We brought map, and we brought the, if I take out this guy now, I think we should throw an error. Yes, it will throw an error. You see, we cannot use it here for the map operations. Are we together? Uh-huh. So, okay, I just need to control that. So now, in our storage, we define a variable balances. You understand? So the balances is what type is it? Map. So what's the key of this map? A contract address, and the value is a file. Are we together? So that's how we defined the storage mapping. Then we came down to use it. So we read before, so now we want to update each address that calls the increase balance. We want to call that, we want to calculate for everybody that calls that function individually. In the beginning, the Hello Starknet contract was just updating balances generally. Are we together? I'm looking lost. Are we together? Okay, nice. So now, this is how we read from the mapping. This is the mapping name, self dot balances. That's the name of the mapping. So the N3 is the caller. It's just like, okay, you want to read balances who is the caller. Are we getting me? Dot read. That means you are reading it. Because I think there's another way to read and write. I'm going to show you after our break. So, and this is how we write. You get, this is the key and your value. Yes. This one is key and this is the value. Are we together? Does it make sense? Is there anything that I've been saying so far that doesn't make sense so that I can go over it? We're good to go? So now, I think we're going to look at the concept of modules and scoping. So what's a module? Any concept, any idea? Huh? You guys are not giving that vibe. Although I really would love this to be, interaction. So okay, a module is a group of related code. It's when you group related code into logical units. So now you remember when I said our entry point is what's the entry point to a Starknet contract? Good. So for instance, if we have a very big code base and we don't want to lump everything in one file, we can break them into modules and we can import all those modules into the Cairo and it will run it. I don't know if we're together. So for you to make a module accessible from another module, yeah, you give it, you type it public, that's pub. Without pub, it remains private. So you can create a module, but it should not be accessible if you don't make it a public module. So the benefit is organizing state, storage variables, and implementation into submodules. Supported scoped import, preventing naming conflict. It enables clean architecture for large projects. Each module can be developed and tested independently. So this is enough talk. So let me show you what I mean by that. Let's escape. Let's go to our code base. So now everything here is in the little Cairo. So into how many modules can we separate this? Okay. So we can start, we come to source. In source, we can create a new folder. We name it hello Starknet. Hello STRK start hello Starknet like this dot Cairo. So why do we use the dot Cairo? Okay. Just like if you're writing a JavaScript is .js, you're writing a type script.ts, a JSX, a TSX.py for Python, .c, yes, out.html just is the extension that shows that we're writing a type of Cairo. So we can come here People are causing eye problems want to catch me, but we can come here and take this module out and we put it here. You see now this place is crying. I don't know where that module is, blah blah blah. So now, if we want to import it here, we come. There's something in the scarf.toml. It tells us the name. So this is the name of. If we want to can change it. If we want to can edit the name, should we change the name? Okay. So currently the name is Starknet contract. So it's in your scarf.toml line 2. If you're looking for the name of. Okay, I'll show you where it is. So you can come here now and set use Starknet contract dot I think hi hello Starknet. What's wrong? Okay, identify not found. Okay, no, I can't use it here just yet. So here I can make it a public module. Hello Starknet, I think. Yes. Okay. Then inside this module here, I can come. Sorry. Unspecific. It's the dispatcher and the dispatcher trait I need to bring. You make it like this. Sorry, because it's public. Okay, let's make it 3 modules at once so that this will not confuse me anymore. So we can have our second module is hello Starknet dot yeah. Are we together? Are we together? Or am I confusing you guys? Then I can come and pick it up here. And pick it up like this. And I'll drop it here. Okay, but it should show an error very soon. Yeah, then we can make it pub module hello Starknet. It's throwing an error. Why is it throwing an error? This should make this a public module. So it's throwing an error because it can't see this guy. Are we together? So we can use the Starknet contract. Let's see. Starknet Starknet underscore contract. That's the name. And it did like this. Then we have yes. Let's see. So what's the problem now? Trait not found. Sorry. I'm coming. The public trait here. Hi hello Starknet. Yep, hi hello Starknet. I'm coming. Something wrong here. Okay, super. It's no longer super because it's in the module. If we want to make it super, we take it outside the module like this. Then it's only. I don't know if you are getting my point. Did you see what just happened now? If it's inside the module, it cannot be accessed as super. Are you together? So if I want to use it here, I'll just do what? What should I do, guys? Remove the super. Or remove the super. Are we together? I showed you 2 things now. If you import it inside the module, we don't need the keyword super. You understand? But sometimes you can choose to just import it on top of the page. Then you can use super. And the main reason why we are seeing this thing is all because we've defined it here. So now if I come and I comment this out, if I come back to here, it cannot see it. Because it's telling you unused. Okay, yes, it's telling you identifier not found. Are we together? Are we together? Are we together? So let's uncomment it out. Let's bring it back. Are we together? So now, still in the concept of scope and modules, Let's see now we have, I'm supposed to keep guys now. Okay. Yes, yes, good. So, and remember, if you finish writing, I didn't think I showed you guys, we can compile, like compile, you can use scarp build, we use scarp build, compile what we've done. So when you finish writing your code, to be sure what you did is correct, you build it. It it throws you warnings, and if there are errors, if there are warnings or errors, you get them when you run scarp build. If you want to format them properly, you run scarp FMT, just like the way you run Forge and FMT in Foundry for Solidity. You run, and yeah, so our code is correct. So still in the concept of scope and modules, this is us importing single files. What if we have them in folder structures? So let's see folders now. Let me add a folder, interfaces. Interfaces, am I correct? That's the folder. Then let me add another folder, contract. Are we together? Let's move the contract into contracts. Are we, you understand what I did? Let's move the interface into interfaces. Are we together? Now even the libel.cairo can't see them. So now how we do it is you come here and you do Control Z, let me do something, Control Home, Control C, Control I. You write the name of the folder, interfaces like this. Yep. Are we together? If there's another interface, public mode in it, are we together? Hmm? So how do I do this now? Huh? Contract. And everything is passed. But we're going to have an error here now. So what's the error here now? It's because it's no longer there. So now it's in Starknet contract in interfaces. Yes, yes, yes. Okay. So if you want to use Open Zeppelin, you import it. I'm not. I'm going to get. You're going to get there, but just to give you context, you import it in your scarp.toml, then you access it. Use Open Zeppelin, just like the way I did. Use Starknet and then contracts. You can use Open Zeppelin, then you can access the file you're looking for. Yes. So guys, any questions? So okay, no questions. I said I'm going to show us another way to read and write to map back. Control C, not Control Home. Where is it? This is storage path entry. Let me do this. Let's Control B so that everybody can see. Good. I need the map. So let me put the map in the beginning. Map. So I think that is storage map read access. Then I have storage map write access. I think the first one we used to just use storage map entry. You understand? Are we together? So now for the other way that you can read and write to a mapping is just storage map read access, storage map write access. So we can come here now. I can comment this one out. Then, then I can say let unique balance equals to self dot balances dot read column. You see? So there's no, it doesn't have that dot entry dot y, and so it does the same thing. Are we together? Are we together, guys? Are we together? Yeah, if you want to do the amount, yeah. Are we together, guys? So you have seen the both ways to read, alright. Me, I prefer the later method though. I don't usually use that dot entry dot. You get me? It's direct. It's just dot read, alright. But remember that if you try it and it doesn't work, it means maybe you haven't imported this guy or the other guy. You get? So that's some things that you might be missing. Anytime you see your read or your write has a red, that red underline, it's maybe we have you haven't imported something you're using. Are you getting me? Either the read access or the write access. If you want to use get contract, get caller address, you need to import it. If you want to use contract address, you need to import it. If you want to use get block.timestamp, you need to import it. Are we together? So there's no method of value in Starknet because Starknet is a layer 2 on top of the Ethereum. You understand? So Starknet, every token you have to implement it as an ERC20 token. Even its native token is implemented as an ERC20 token, not like for Starknet that has a native token. And for Ethereum on Solidity, I mean like a manipulated message to sender. Are we together, guys? Any questions? Any questions? I told you. Well, I'm supposed to finish very soon. Yeah, yes, I will. I will. And I'm going to give you guys an assignment. Yes, everything. No, you can't. You can't. Because that means you want to read the Ethereum balance of a particular address. Yes? No, you can't. You have to use Open Zeppelin, then you query the balance. Are we together, guys? Please, I'm listening to questions. So, okay, so last something else we're going to talk about in the overall architecture. We're going to talk about events. We know events now. When you want to signal a change in state or something, you want to alert either an indexer or the front end to something happening. So we write events like this. Have the event EVENT. Yeah. It's supposed to be here, EVENT events. Then we're going to have, no, we're going to first define them, derive, then you can, oh, what am I doing? Then you can and you have Starknet events. Is it a capital S? A small letter, S-T-E-R. Starknet events, okay, see it here, good. And what's wrong? Because I've never defined it. Then you do a public enum event. Yes, balance increased. No, nope, this is wrong. AI doesn't know everything. Okay, can do. Balance, increased. Yep. So it's still complaining because we have not defined it. So now we can come here. Yes, but it's just events. Don't mind me. It's just events that I need here. Then we can have struct. Yes, I think so. Yes. Do I really need the public? Do I really need them? But let's see. Then you can come here and you can write This is how you emit an event. Self dot emit emit. Then we have balance increased. Then we have color and amount. Yes, this is how you emit an event. Well, so now any event, yes, you have to define all the events you want to use so that you can call them. Are we together, guys? So does this make sense? So I think we'll go through just one more contract again. Then I think I can. Then I think it's safe to say yes. So we use the last. We have just 30 minutes. So we go through another contract. You want me to go through the event again? Okay. So this is before you write an event, or you can write an event, but this you have to define the event enum with the name of the event you want to use. Are we together? Are we together? If no, it's the name you want to refer to it as and the name it is. Like let's see now. If I change this now to balance, hmm, it should throw an error on that, I think. Okay, it didn't. I was expecting it to throw an error. I'm coming, let's see. Let me try something. Okay. Balance was not found, type not found. Okay, balance increased. So when I'm coming, why really need was this needed in the first place? Yes, yes, it was. So okay, but now if okay, so the name here is inconsequential. Is that what I'm seeing? I'm coming, let's see. Okay. What was your question? This is the name here. So this is the name of the event here. I'm coming. Let me build this. Okay, I think I'm trying to think why. Let's build it and see if it will come with any warning. Meanwhile, let me pick the contract I want us to work on. Okay, I'm sharing my screen. I had a simpler contract that I wanted us to work on. So yes, you name them and yes, exactly. Yes, yes. So, Uche, I think I'll get back to you on your own question later. So let's see now. We have we have another this one is counter.so and dot Cairo. Counter.Cairo. So I'm going to drop it here. So okay. So now let's see how it works. So now if we want to separate this, so now the first thing we'll do is what? What's the first thing we should do? So that it becomes visible. We'll go to our entry point in leap. We'll come to it's in our contract. Are we together? We'll now create another. What will we create now? Oh God. And then, so are we together? Like I want us to do some another thing so that we'll see how this thing is moving. Are we together? So we'll create another public module counter. This is why it's named counter because this guy here is counter. Are you with me? So if I save it, I think all the errors in counter will show up now. Yeah. Yes, there are a lot of errors. There are a lot of errors in counter. So let's continue. What can we do to counter now? We can extract the interface. Yes? Are you sure? Are we together? We can extract the interface, yeah? So we can come to interfaces, create a new interface and name it I counter. So we can come to counter, pick this guy up and take it here. And I want you to notice that the errors only pop out when you introduce it to lib or carry. See, if you take counter out, you see counter will become error free. It's supposed to become error free now. It's supposed to become error free though. Yes. Anytime if the compiler is not seeing it, if we build this, I think it will build successfully. It should build successfully by the time we build it. Because now the entry point is not aware of counter or carry. I don't know if you get my point. So the only way you can compile or you make it aware. So when you are troubleshooting, sometimes when I'm debugging and it's still on a large scale, what I start doing is I start commenting out whole modules. That's why modules, the concept of modules makes sense. Are we together? I just comment out the whole module so that I'll be able to pinpoint where it's giving me issue. By the time I track it to a specific module, then I leave only that module uncommented. You see, it builds successfully. Like, in 40 seconds. Now, tonight, tell you that I've run into problems, a lot of problems. Tell you that you have 5 errors and so on and so forth. You see, that started warning. Are we together? So now we see how important lib or Cairo is. If you want to have, if you want your code to be compiled, you have to find a way to import that module or that logic to your lib or Cairo. You can either write it directly there, or you create a module and you call that module in lib or Cairo, just like I've done. So now I'm going to have another module for my interface. If you understand the concept now, yes. Mhm. So I can go to iCounter. Why is it not taking me there? Let's go to iCounter. Okay, iCounter is okay. iCounter is okay. Then we can come to count.cairo. Let's see. What is our error? Okay, count alright. It's not, it doesn't know who iCounter is. Are we together? So now we can use Starknet contracts, yes. Interfaces, okay, so let's see. Let's debug. So it's still complaining. It's supposed to know iCounter, yes? It's not super. Okay, it's not super. Thank you very much. It's no longer super. So it's now went to 8. Read and write. So what what to use okay, storage pointer read access, pointer write access. Uh-huh. And we're done. So it says unused import. So let's comment it out. Then what's the next unused 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 import. I like to see my code. Good. So everything is good. We can choose to import this guy here. So let's put everything. We can choose to put everything inside there. Yes. So I'm just fixing this now. Yeah. Mm-hmm. Yep. Mm-hmm. Right. I'll get down. So what's happening here? Okay. Yes. So that's our storage holding all our state variables. Yes. Are we together? Yes. Then this an event count updated. and this is the event calc updated. The first one is the old value, new value, and its data type is that's an unsigned jar. Yes. So this is constructor. This is how you write a constructor. Remember what I told you guys about the constructor? A constructor is what? The it's a public, it's a function that runs only once on deployment. Yes. So like other functions too, although it is not defined in the interface, it's not constructors are not defined in the interface. Are we together? They are not defined in the interface, but they to their first argument is always a reference of self. Are we together guys? That's the first that's the first argument of all right functions. Then here, this is the implementation counter. This counter implementation of the interface I counter. Its type is contract state. So get count. The argument is self, but this time as a snapshot of it. And from that snapshot, you just read the count. Yes, you read count, and this count is coming from the storage count altogether. So increment. This is logic. Then you can emit self.emit count updated. Old value, new value, decrement, counter. Are we together? Are we together? So yeah, I think with that, I've finished my slides. We've done. What's your takeaway? Traits for clear interfaces, modular architecture. Yeah. So we've run code and I didn't put and let me put something. Yes. 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 Okay. I'm going to stop sharing my screen for a bit. Um, okay, I will take your questions now. I'll take your questions. You can ask questions. Like I'll take questions from your D1 till today. Like if you have any questions, you have any confusion, you need clarification on any point, either the one I made today or in your previous classes. Are we together? So questions, please. I'm trying to let's see what you're talking about. Okay, so you mean is it optional? So is it up? So here now, let's take just one. Okay, let's give it a try and see. Are we together? I'll look for the answer and give you. Don't worry. Mhm. So yes, any more questions, please? Any more questions, please? It's time for questions. Hi, I can hear you. Okay, there's some. Okay. Can you? Okay. So let me put you on so that we can see your screen. This is Ben, right? Ah, Ben, why not in class? Okay.
Is that when you can see my
Yeah, I'm coming. I didn't put it in mirror. I can't see your screen yet, though. Or do I need to stop? I'm coming. And so, am I still sharing my screen? Okay,
can you see
no.
my screen now?
Yes, I can see your screen.
Um,
I'm coming. I'm trying to. Why can I maximize my own screen? Okay. Please minimize. Mm. Okay, so I'm a bit confused. So where's the error, bro? Where's the error, sir?
all right. Yes, so this question right now in this movie, yes,
See
and then
subtitles.
and then you have this wiki module available. So in this little Cairo, I was just able to use those things inside this file, use the in this wiki and then use this say hi for example inside of this. So it was like we're using say hi function whatever that was inside this
Wiki.
module called yes. So Swiss wiki and then say hi for example. Right. So this was what we did here. And now this works right. But now, for example, in this, because when I was going through what you said, like the whole module in today's class,
Yes.
I was like asking myself, instead of us to go start doing things, taking very complex, what if I just wanted to take this our Starknet, just the definition of the Starknet interface. That's like the Starknet interface
Yes.
direction, just
Yes.
basic like instead of start taking it very difficult, let's start by just taking the interface to one file
Yes.
and then leaving our main comp inside
Yes.
this
Yes. Yes.
file, right?
So
How do we
have you
how
taken
do
the
we bring that in?
okay, have you taken it to one file? Let's see, where did you take your subnet?
Yes, so I took that interface to
Tweak.
this yeah, that's like to yes, to this random file called it tweak. And
Okay.
then I put the interface declaration here.
Okay, in tweak.
So I was now say, okay, let's start by bringing this ISO to the form. This
Okay.
ISO started interface. Can we just bring directly inside the file without
Okay.
let's start by doing that? Yes.
Okay.
So I
Okay.
don't know, I was trying to work around it, but I don't know why it was not working. I tried several things, but it didn't work. That's why it was not problem. So how will you bring that interface in first for it to work correctly, right? Because what I don't want to like so I have to use something I use and then create, which is the name of the whole package, the
Yes,
whole
yes, use
syntax
create. Yes, yes,
interface.
yes. Use create.
The same thing
But
happened in
you
this.
can go to scribe.com or your own is class 2. You can use class 2 or you can use create. Okay, let's try it because yeah, because me too I tried it, but it was not working. But okay, let's try it now. Continue. Yes, use class 2.
So I use tweet and then this file is the name of the file. So I'm
Yeah.
going to bring right like
Yes, bring tweak.
then I'm
Yes.
supposed to bring
Access
this
interface.
bring that name here.
What's the name there?
This
I
I just
hello.
started.
Okay, take it there.
Yes, so I put it like this.
And it's not working, yeah?
So now it's not working right.
Yes.
So I'm saying okay, I just need to
If you
like
do
this part that we're doing here. And then do I need to bring the module
okay, wait.
to the last time?
Try and bring in the module on top. Go back to where you are. Go back and try and bring the module on top. Let's see. I will try and bring in the module. Pop,
Do I do
pop mod pick. Mod pick. Yes. I will, it's on the same file. I will try that. So what's it saying? Then you cover it.
okay? Okay, so that means I need to bring okay. But the thing, what was confusing was I don't know, is there every file of my phone post and
Now they cannot have
Okay,
visibility.
module thing is not really clear. But in terms of
So,
uh,
okay, the module thing is not clear for you. So the concept of module is just like what okay, what do you think a module is?
like from JavaScript, like a module is like you like keep a chunk of functionality and leaves in one word, and then you have it living in that word. You can now import it into another module again. And that's why you can create applications that compose it. That's one
Okay.
aspect.
So
So
here,
yeah, so like
so now modules like they are when you like a group of just like you said, a group of related logic like is how I put it now. You are trying to you can write everything in you can write where you let me sorry. You can choose to write everything in your lib or Cairo because it's the entry point. Huh? So the modules is like because you can have components too as modules because it's not only contracts are modules. So modules are just like a group of code that work together. Just trying to you have to work to use it. When you want to like when you want to understand. Like, let's say if there are students, you can say, okay, all the students in this age group be in this class, be in that this age group, be in that class. It's just like a way. Are you with me, Ben?
yeah, that makes
So the concept of module here is just for it's just like I don't want to say I don't want to say libraries in solid. It's just like when you modularize your work, you break your work down into different files. Then everybody meets and partake in the lib or Cairo. I don't know if it makes sense.
all right. So this is what you said again.
It's just it's
Last time.
in the last line of what I said, everybody meets and because the lead or Cairo is the entry point. So everybody, if any piece of code has to be recognized on your in your contract or in your whole package, it has to has access, it has to be reached from in the lead or Cairo. So the lead or Cairo is where if you run the compiler, it's where it executes everything. It compiles everything in the lead or Cairo. So modules are just like a group of code that you just destructure, like codes that move together, that work together. Most of the time, they can be whole contracts, they can be interfaces, they can be components. It's just like I don't know if I'm making sense though. I'm rambling. I don't know if
And it
it's
makes it out. Okay.
you understand? So, but once you want to make that module, if you want to include to show that the module is part of your code block, you have to import it in the lib.cairo. It has to be shown in the lib.cairo. I don't know if it makes sense.
Okay, that makes sense now. Okay.
Are
So
we?
you so only when we nest files inside folders, you have to
Yes.
create this kind of
Yes. That's the folder.
okay. Right.
Are we
We're
together?
together.
Okay. Your error. I see your errors have disappeared.
It's good.
Oh, okay. Thank you very much.